So in this video, I'll be doing a walkthrough of the June 2020 Higher Paper 3. Let's make a start. Question 1, we've been asked to simplify the following. So when you multiply two indices together, you add them. So that becomes n to the power of 8. The next one, we are dividing indices. So when you divide indices, you subtract the powers. So we are left with c, which is 3 minus 2, and we are left with d squared, which is 4 minus 1. Not squared, sorry, cubed. The following one is an inequality, so we have 5x over 2 is greater than 7. We can times each side by 2 to get rid of the denominator here, so that's 5x is greater than 14, and we are left with x is greater than 14 over 5. You can also write that as a decimal, which is 2.8. Question 2. Andy cycles a distance of 30 kilometers. Then he runs a distance of 12 kilometers at that speed. Work out the total time Andy takes. Give your answer in hours and minutes. So speed is equal to distance over time. When he cycles, we can sub that into the formula. The speed is 24. The distance is 30 kilometers. And then we have time at the bottom. We can rearrange this and we end up with time is equal to 30 over 24, which is 1.25 hours. And then the other one is when he runs. Again, we can sub into the formula speed is distance over time, so that's 8, 12 over t. We could rearrange this for t, which becomes 12 over 8, which is equal to 1.5 hours. And then in total, that is going to be, so total is 1.25 plus 1.5 hours, move the h there, and that becomes 2.75 hours. Now we know that 1 hour has 60 minutes, so 2.75 hours are going to have 165 minutes, and that is 2 hours and 45 minutes altogether, because 2 hours have 120 minutes, and then you take 120 away from 165. And just a quick note here, in case you're wondering, well, how does this become an hour? How did I know the unit of this? So remember, time is equal to distance over speed if you rearrange that. So they told us the distance in the question is in kilometers. They told us the speed is in kilometers per hour. So now what we're essentially doing is dividing. So we have kilometers divided by the denominator, which is kilometers per hour. Now we can use the KCF method. So KCF, so km times h over kilometers, and you are left with the unit of time, which is hours. So question 3, m is rounded to one decimal place. The result is 9.4. So that's essentially 0.1 there. So we have 0.1, and the accuracy will be divide that by 2. So that's going to give me 0.05. So the upper bound, we're going to add 0.05. So that's going to become 9.45. And for the lower bound, we're going to take away 0.05 from 9.4, and that's 9.35. Question 4. So she needs 3 kg of grass seeds to make a rectangle lawn, 9 by 5. Grass seeds are sold in 2 kg boxes. She wants to make a rectangle of 10 by 14 meters. She has 5 boxes of seeds. Has she got enough seeds to make the 10 by 14? So firstly, they've told us 3 kg is required for a 5 by 9. So if I do 5 by 9 here, so that means the area is 5 times 9, which is 45 meters squared. So we know that 3 kg requires 45 meters squared. Now we know she wants to make a 10 by 14. So the area is going to be 10 times 14, which is 140 meters squared. And we know she's got 5 boxes. So 5 times each box has 2 kg. So in total, she has 10 kg. So we need to figure out whether she has enough. So there's 2 ways you can really go about this. So the method I'll use is I'll bring this down to see how much area 1 kg covers. So in this case, 1 kg, I'll do meters. So how much does 1 meter require? So 1 meter divided each side by 45 requires 0.067 kg. And we have 140 meters squared that she needs to cover, and that requires 9.33 kg. So she needs 9.33 kg and she has 10 kg. So has she got enough? yes, she has enough, and then you would just write that she requires 9.33 kg, but has 10 kg. So the next part of the question, she opens the 5 boxes and finds that one of them has 1 kg and the rest have 2. So that means there's 4 boxes with 2 kg, which becomes 8 kg altogether. And then there's 1 box with 1 kg. So that's going to be a total of 9 kg. Does this affect whether she has enough grass? Grass seeds to make her lawn. Yes, she needs, from what we've calculated, 9.33 kg, but the 5 boxes only have a total of 9 kg. And it's also good to leave this working out here as well, because the examiner can then see it. So question 5, you've got 2 spinners. It's saying write down the probability that it lands on 2. So for spinner A, the probability that it lands on 2 is 1/3. So the probability that it doesn't land on 2 is 2/3. And it's the same for spinner B, which is that one there. The probability that it lands on 2 is 1/3 and 2/3 that it doesn't. And it's the exact same here. So the next part of the question asks us, work out the probability that spinner A lands on 2. So that's going to be this one there. And spinner B does not land on 2, so that's going to be that one there. So that is going to be 1/3 times 2/3, which is 2/9. That was nice and easy. Moving on to the next question. Use the graph to solve the simultaneous equation. So it's specifically saying use the graph. So simultaneous equations are points where the lines intersect each other. So that is that point right there. And the coordinates of that point are x is -2 and y is 4. So that's along the corridor, the stairs. Moving on to the next part. Use the graph to find estimates for the solution of the quadratic when this equation is equal to 0. So that is essentially when it passes the x-axis. So that is that point there and that point there. Now you want to read these off as carefully as you can. So the estimates would be 0.6 and 3.4. But you want to be careful and not write this like this, because if you write it like this, these are coordinates x and y. So just take a bit of care there. So moving on to question 7. So there are a total of 45 boys and girls. The mean age of 18 boys is 16.2 years. The mean age of 27 girls is 16.7 years. Calculate the mean age of all 45 boys and girls. So essentially, the first thing we probably want to write up here is that the mean is essentially the sum divided by n, which is how many they are. And we have 3 parts to this question. So we have boys, we have girls, and then we have total. And now this is what the question is asking for. It says work out the mean of all 45. So if you wanted to work out the mean for the total, that would be the sum divided by n. Now we know what n is because there's a total of 45. So what we're missing here is the sum. So we're going to look at the boys and the girls information that they've given us in order to get the sum out. So for the boys, we have the mean. So if I sub it into that equation, the mean is 16.2, which is equal to the total over this 18 boys. So I'm not going to call it total, sorry, I'm going to call it the sum. So the sum of boys, so I'll just write here, sum of boys is going to be 18 times 16.2, type that into your calculator, that's 291.6, and then for the girls, it'll be the same, so 16.7 is equal to the sum of the girls over the number of girls. So that means for the sum of the girls, we have 450.9. And now this sum up here for the total is going to be the sum of the girls and the sum of the boys. So we end up with the mean is equal to 291.6 plus 450.9. Divide that by 45 and you get your answer. Well, that totals up to 742.5 and your answer becomes 16.5. Moving on to question 8. So we've been given some information about some counters. This bit of the question is key. So it says there will be the probability of getting a 5 is 5 times the probability that it's yellow. So if this is x, this is 5x. Now, whenever you don't know anything, we just give it a variable. So in this case, it's x. So we know that the probability totals up to 1. And the question's saying there are 300 counters. Work out the number of yellow counters in the bag. So first thing we need to do is work out the probability of the yellow counters. So in that case, we can have 0.32 plus 0.20 plus 5x plus x is equal to 1. If I collect all the like terms, we have 0.52 plus 6x is equal to 1. Subtract 0.52 from each side, and I end up with 6x is equal to 0.48. Divide each side by 6, and I end up with x is equal to 0.08. And now there's 300 altogether, so we'll do 300 times 0.08, and that gives us 24. Moving on to question 9. So they've asked us to work out the volume of this prism. So just so I get the formula down here. So we have the volume is equal to the cross section times length. Now, what do we already know? So we know the length here is 20. So that's that number right there. That's the length. And the cross section is essentially this area, that area there. We need to find out what this area is and multiply it by the length. So we know the length. And I'm just going to get my highlighter and draw on the cross section just so it's a little bit more clear as well. So if I grab my highlighter, there we go. So that is my cross section, and actually I'll draw a line through it as well to split this shape. So it's actually made of two shapes. There's a triangle at the top and a rectangle at the bottom. So we can call this B and we'll call this A. So the where should I do it? I'll do it here. So the area of B is straightforward because that's just 12 times 10, which is 120 meters squared. Now the area of A, it's a triangle, so it's going to be base times height divided by 2. We know the base is 10, so it's 10 times height divided by 2. Now what we're missing here that we need to calculate is the height of this triangle. So I'm just going to draw this triangle out here on this side. Let's see if that can get picked up. Now let me just try one more time. Okay, we'll leave it at that. So essentially it's that blue triangle. Oh, there we go. So we know that the base is 10, and if you split that in half, what we're actually looking to find here is this height here. We know each side is going to be 5 and 5 because the base is 10. We know the angle here is 40, and hopefully you can see we can again write that as essentially just half a triangle. So that's 5, that's 40, and we're trying to find this missing side. So this is the opposite, this is the hypotenuse, and that's the adjacent. Now we're trying to find the opposite. We don't know anything about the hypotenuse, we can cancel that out. That leaves us with the opposite and the adjacent, so we're going to use a tan. Theta is equal to the opposite over the adjacent, so tan 40 is equal to the opposite, which we don't know, over the adjacent. I'm just going to label that as opposite so it doesn't look like a 0. The adjacent is 5. So if you do 5 times tan 40, you will end up with the opposite being equal to 4.19549. Now remember, the opposite is actually this bit here, which is the height. That's what we were trying to calculate. So now we know what the height is. We can do 10 times 4.19549. Divide that by 2, and you get your answer coming to 20.97749. So now we have the total area of the cross section, so we can write that here. So that would be 120 plus 20.97749. Times that by 20, and you get 2 3 significant figures, 2820 centimeters cubed. Moving on to question 10. So a person's heart beats approximately 10 to the power of 5 times each day. So one day is equal to 10 to the power of 5. A person lives approximately 85 years. So if one day is that much, we then have 1 year, and 1 year is essentially 365 days. So if I times each side by 365, on this side I get 3, 6, 5, 1, 2, 3, 4, 5 zeros on my calculator. And now that's 1 year, so 81 years. I will just times that by 81 on each side, and that gives me, in standard form, they want the answer, two significant figures. So you will have to round your answer up, and it becomes 3.0 times 10 to the power of 9. And the 0.0 is important because it wants it in standard form. So we have 2 times 10 to the power of 12 red blood cells, give a total mass of 90 grams. Work out the average mass of one red blood cell. So 1 red blood cell means I'm going to divide each side by 2 times 10 to the power of 12. And when you do that in your calculator, again, it wants the answer in standard form, which you get to 4.5 times 10 to the power of minus 11. I've now used this tool over here, where essentially what I've done is I've plotted the exact same shape that we had there. I'm just going to hide my tracing paper for now, and I've put the center point on. If I show my tracing paper, I'm now going to rotate 180 degrees. It doesn't matter if you go clockwise or anti-clockwise, and you end up there when you rotate 180 degrees right there. And you could have also gone anti-clockwise, and you'd end up at the exact same place using tracing paper about that center. So the first coordinate there is -1, -2. So if I now head back to where I was, the first coordinate here was -1, -2, which was that one there. And then I can just figure the rest out from there. So it's going to be down there and there. And if I connect them points together, I end up with Q. This is called Q. So I've done the first bit of the question. The second bit says Q is translated by 5 minus 2 to give R. So 5 minus 2, so if I move the first point 1, 2, 3, 4, 5, and then -2, so that ends up there, and I can figure the rest out just from the height of the shape. So that then becomes R, and you want to you definitely want to be drawing these on the graph. And then it says describe fully the single transformation that maps P to R. So if you have a look at P and R, we can see that they've been rotated by 180 degrees. So we can see that straight away. It's a rotation by 120 degrees. The only thing we don't know is the center of rotation. Now to find the center of rotation, you're going to get your ruler and draw a line through the points. So I'm going to make sure they're the same 2 points. So in this case, I'm using the top of both triangles. And if I draw a line through them, and then I'm using the right angle corner of each triangle. You want to be as accurate as you can here, so I am trying my best to line this up. That's that there, and then finally you've got this edge that's left here. And if I draw a line through there, and you can now see all of these lines cross at that point right. Well, I'm going to use some highlighter for this one. That point right there, and that has the coordinates of x as 2.5 and y as -1. So we're going to say it's rotated 180 degrees about 2.5 -1. The next question, under this transformation of that maps P to R, the point A is invariant. Write down the coordinates of point A, so that's the point that we found just then. So for question 12, it's asking us to express the following fraction as a single fraction in its simplest form. So the first thing we're going to do is make the denominators the same. So if I just write this out, we have x over x plus 2 over x minus 4. So times the top and bottom of this side by x plus 2 times the top and bottom of this side by x minus 4. So essentially the denominators now become x minus 4 and x plus 2. So the denominators are now the same. And at the top we end up with x bracket x minus 4 plus 2 bracket x plus 2. That should say x there. And then if you expand that out, that becomes x squared minus 4x plus 2x squared plus 4x all over x minus 4, x plus 2. Now this and this cancel out, and that leaves us with 3x squared all over x minus 4, x plus 2 as a single fraction. So the next one is asking us to expand and simplify 3 sets of brackets. I like to work left to right with these, so just going to write that out. So I'm going to expand the 2 brackets on the left first, so that's going to become that times that, and that times that, so that's going to be 2x squared plus 3x, and then that times that, which is minus 6x minus 9. And then we're left with what's still there, and now we're going to simplify what's inside the brackets in the left, so we can collect these 2 like terms, and that becomes 2x squared minus 3x minus 9, and that's 4x plus 5. And now we can finally expand these out. So the first, we're going to multiply this by that, and then the first term by the second term, so that's going to become 8x cubed plus 10x squared minus 12x squared plus, minus 15x. You want to be careful with the signs here. Minus 36x minus 45. And then just collect the like terms. So 8x cubed minus 2x squared minus 51x minus 45. Question 13. So it's asking us to plot the points, plot the lines for the following inequalities and shade the region that satisfies, well, it says just label the region. Okay. On the grid by shading, there we go, by shading. So if we start off with this one, go to the x-axis, find x is 0, and that's right there. Draw a line through there. That's that one there, and that is x is greater than or equal to 0. The next one is this one here, so that is x is less than or equal to 2, so that is x is less than or equal to 2. The next one is this one here. Now remember, the equation of a line is y is equal to mx plus c. So c is the y-intercept, so we know it's going to cross that point there. And we know for every one it goes across, it goes 1 up. So the line is going to look 1 across, 1 up for the gradient, because the gradient's just 1. So the line is going to look something like this. Now I'm just going to draw a point through that. There we go. And I'll label this, that is y is less than or equal to x plus 3. And we're left with the final line. Now that's not in the form y is equal to mx plus c, so we'll move the 2x over. So that then becomes 3y is greater than or equal to minus 2x plus 6. We can divide each side by 3, so just so we have y on its own. So that's minus 1.5x plus 2. So we know it goes through 2 as the y-intercept, so we know it's going to cross this at some point. And for every 1 it goes across, it goes down by 1.5. That's using the gradient, so we know that we can plot these points on for the line. If I was to draw a line through these points, it would look something like, there we go. And now it wants me to label the region R, so that region is going to be that one there. And if I shade that in a slightly different color, it's going to be that. So B, we also have something similar that's done for us. So says that the point 2,4 does not satisfy the inequality. So the point 2,4 is that point there, and that is the line. So it crosses the x-axis at 6, so it must be that one there. So it's essentially y, x plus y is less than or equal to 6. Does not satisfy the inequality. Well, you can sub the points in. So this is x, this is y. If you sub in x and y into, so you have x plus y is less than or equal to 6, sub in x and y in there. So essentially you end up with 6 is less than or equal to 6. So is he correct? No. Because the points 2, 4 satisfy x plus y is less than or equal to 6. Question 14. So we've got B, D, E, and F lie on a circle. It wants us to find A, B, D. So A, B, D, if I just draw that on, is that one there. So you need to use your circle theorems knowledge here. The first thing I can see in this is that, yeah, there we go. That's the first thing I see. So that DBF is equal to 180 minus 100, which is equal to 80 degrees. So I've figured this out as 80 degrees because opposite angles in a cyclic quadrilateral equal to 180. So you'll have to write your reason as well. So opposite angles in cyclic quadrilateral add up to 180 degrees. So that's my reasoning for that much. And we know that ABC is a straight line. So essentially, if I can figure out what this bit here is, I can solve this question. So in order for me to figure out what that bit there is, I'm just having a think. So there's a few ways we could go about this. So well, one way that's coming to me is, well, I can find out what this angle here is. So I can find out that PFD is, because it's angles in a triangle, it must be 180, take away 80 minus 40. That's 60. You can just write angles in triangle. Add up to 180. So now that I know what that is, I don't actually need to now worry about the straight line because we can use the alternate segment theorem here. So using the alternate segment theorem here, I should probably just switch back to that. So ABD is equal to BFD, which is 60 degrees, as we just calculated. And that's the alternate segment theorem. So essentially this angle here and this angle here are the same. And now that I look at it, you could have even done it like this. This angle is 40, so this angle is also 40. So you could have also gone down that route as well, where you could do 80 plus 40 and then angles on a straight line. But yeah, both methods are fine. So question 15, prove that 0.73 reoccurring can be written as that. So we'd start off with x is equal to 0.7333. 10x is equal to 7.333. We're essentially trying to line up the part after the decimal point. So if I times that by 10 again, and you'll see what I mean. So now, notice the part after the decimal is exactly the same. So we can subtract these two, which gives us 90x is equal to 66. And then we have x is equal to 66 over 90, and you can simplify that to 11 over 15. Moving on to question 16, work out an estimate for the distance the car travelled. So since we have a speed time graph, distance is always the area under the graph, so you want to remember that. So in this case, the first 30 seconds, and it's asking for an estimate. So if I draw a line down from there to there, it's a triangle, so it's going to be the base times height divided by 2. The base is 30, the height is 8.8. You want to be careful here. Each one of these small squares represents 0.4. And then if you type that into your calculator, you get 132 meters. So the next question is asking us, is it an overestimate or an underestimate? It's an underestimate because we haven't taken this bit into account. So we are going to write exactly that. So we're going to say it's an underestimate, as it does not include area between the curve and triangle. So Julian has used the graph to find the acceleration at time 60. That's working out. So acceleration is the change in speed over time taken, and to work out the acceleration, just for a bit of context, at 60 seconds, what you would actually do is create a point there, and you'll use a ruler to draw a tangent at that point. And once you've worked out that right tangent, you'd find out that using the gradient of the tangent what the acceleration is. That's how you work out the acceleration. So it doesn't give a good estimate, so essentially you can write exactly that we just said, that you need to use tangent at 60 seconds, or need to draw a tangent at 60 seconds. We've got a histogram about some information of 80 competitors in a jumping competition, frequency, density, and distance. It wants us to find an estimate for the mean distance. So we'll need to work out what the sum is and then what the total is. So we have the frequency, density, and the density. Right, okay. So we have 4 parts to this graph. I'm just going to label them. So that's A, B, C, D. A is going to be 7.2, so the base of this minus 6.4 times the height, which is 10. That's going to be 8 meters squared. B is going to be 7.6 minus 7.2 times 50, which is 20 meters squared. C is going to be 8 minus 7.6 times 100, which is 40 meters squared. And D is going to be 8.2 minus 8 times 60, which is 12 meters squared. And then the mean is the sum divided by how many they are. So in this case, we have 8 plus 20 plus 40 plus 12. And then the sum is going to be 8 times the midpoint of this. So in this case, that's going to be 6.8. And then for the next one, it's the same. It's going to be 20 times the midpoint, which is 7.4. And then the next one, it's going to be the midpoint, which is 7.8 times 40. And then finally, for the last one, I'm going off the page a little bit here, but it's going to be, again, the same thing. It's going to be 8.1 times 12. And then that would give us, type that into your calculator, you get 7.645 as the mean distance. Moving on to 18, so we've got a cuboid, and a cuboid, all sides are of equal length, and it's saying edge, and just to be clear, by edge, what it means is this. This is referred to an edge, so if I just grab my highlighter, that is an edge, that is also an edge, that is also an edge. Okay, so in a cuboid, all edges have the same length, so we can call any of these x, and they've told us what A to H is. If I just grab my line there, they've told us A to H as 11.3 centimeters to the nearest millimeter. And now, just so write this down, 1 centimeter is 10 millimeters. And if I was to draw that out here, well, what they're actually asking for is the length of an edge. And the edge, like I said, is any of them sides outside. So if I draw out what they've given us, that is that, which is A, that is H. If I draw the base there, and then that there. So this can be, for example, F, which is, if I just grab my highlighter, actually it'll be a little bit easier. So that's that there. And then I'm joining that with that bit there. And you'll see why I'm doing that in just a second. So this is going to be, we're going to call this, like I said, X, because every side on this cuboid, or every edge has the length of X. We know that A to H is 11.3 centimeters. And then the lower bound of this is going to be 11.25 centimeters. So we're going to have 0.1, divide that by 2, which is 0.05, and we're going to subtract that. And then you have F to H. Now, F to H is not X. What F to H is X here and X here. So in order for you to find out what F to H is, you'd have to use Pythagoras theorem. So that would be x squared plus x squared, and that would then become 2x squared. Is that bit there. So this here is 2x squared. not choose the square root because for Pythagoras theorem, square it, add it, square root it. Yep, so that will be with a square root there. And then now we can figure out what x is, because we can essentially do exactly what we just did there. So if we'd used Pythagoras again here, we'd have x squared plus root 2x squared, which would all be squared, is equal to 11.25 squared. Now, with this bit here, the square will cancel out the square root, so we have x squared plus 2x squared is equal to 11.25, and then that's 3x squared is equal to 11.25, and then squared, and then divide each side by 3 and square root it, and you get x is equal to 6.49519058. So a bit of Pythagoras there, but hopefully that wasn't too difficult. Question 19. So essentially what they've got is a hexagon that's been enlarged by a factor of p. So initially the length of each side here is x, 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 and then after they've enlarged it by a factor of p, the sides now become x times the factor of p, so we're going to call it xp, xp. Okay, so that's after it's been enlarged, and they're asking us to find the area of the shaded region, so we're going to have to find the area of the small hexagon, then the area of the large hexagon, and take them both away. Now, to find the area of the small hexagon, one little trick that you can use is if you draw a line between each of these points, you'll notice a hexagon is actually 6 equilateral triangles. Now, equilateral triangles will have an angle of 60 degrees. So to work out the area of A, B, C, D, E, F, so if I just write that here, A, B, C, D, E, F, the area of the one triangle is going to be a half AB sine C, so that's x squared sine C. And we're going to times that by 6 because there's 6 of them all together. And it's not going to be sine C, it's going to be 60 because each angle in a equilateral triangle is the same. So if you now type that into your calculator and hit enter, you will end up with root 3 over 4. And of course, you're going to times that by 6 as it says there. So that then becomes 3 root 3 over 2. So that is the area of A, B, C, D, E, F. And now we want the area of F, G, H, I, J, K, which is the bigger shape. And it'll be the exact same thing, but this x is now going to become xp. So we'll have area is equal to a half x squared p squared sine 60 times 6. And when you type that in, you'll end up with the exact same thing, but this time you have x squared p squared. I've missed off the x squared here. And now to find the area of the shaded region, we just need to take them both away. So we take away the large one, which is 3 root 3 over 2 x squared p squared. Take that away from the small one. Now notice what's common in these two is, if I just grab my highlighter again, is this bit here and the x squared as well. So you can factor them both out. So then you have 3 root 3 over 2 x squared, and then we have p squared minus 1. And you can see how that looks exactly like what we've got there, other than the fact that they've just put the x squared on that side, which doesn't make any difference. But yeah, moving on to question 20. So the lowest common multiple here is 98 out of 91. Moving on to question 21. So with this, I normally like to, so if I just write that out, I normally like to get rid of the smaller one first. So c from this side, so that's 4c. And then I can get rid of the d from this side. Is equal to 3d, and essentially left with a ratio of 4 to 3. And for the next one, now this one's slightly tricky in some way, but if you move everything over to the left, we have 6x squared minus 7xy minus 20y squared is equal to 0. So all I've done there is moved everything over to the left. Now if you try to treat this in some way as a normal quadratic equation, so we then have two numbers that multiply together to give us minus 120, that I'd also subtract to give us minus 7, so that's going to be minus 15 and 8. So we then can write 6x squared plus 8xy, because this has an xy here, minus 15xy minus 20y squared. So I've just written that down here. And then we can start factorizing. So in this one, we can take out a 2x, which then becomes 3x plus 4y. And we're going to write the same thing here, 3x plus 4y. And we can factor out a minus 5y. And then we can write 2x minus 5y, 3x, just like you'd solve a normal quadratic there. And now, of course, the answer can't be a negative, it must be a positive. So we're going to focus on the left side here. So we have 2x minus 5y. How do you make that a 0? Well, we can do 2x is equal to 5y, it's just like that there. And you can see the ratio there is 2 to 5. And with that, that's the last question. So I hope you found this video useful. If you did, please consider subscribing, and I'll catch you in the next one.